Hello, my name is Millie Douglas, and this is my lab force mission. I'm going to go over my video first, so it is being based off of this lip gloss bottle right here. And so the fundamental physics principles being used is potential and kinetic energies. So I'm defining the system as the earth plus the lip gloss, and so the energy of the system is equal to the potential energy of gravity, which is equal to mass times gravity times delta y, and plus the k lip gloss, which is the kinetic energy of the lip gloss, which is equal to 1/2 mass of the lip gloss times the velocity squared. And so we can also solve this using Newton's second law, which I'm choosing not to do, but we can also use Newton's second law, so this also applies. And it's just finding, if you want to find, like, for example, the final distance, you can get the initial distance, which is given at the start of the video, plus initial velocity, which is also given at the start of the video, which is equal to 0, plus 1/2 of the net force, which is equal to the force of gravity, divided for each bounce, because the lip gloss does bounce, so you have to do this 3 times. So 1/2 the force of gravity divided by the mass of the lip gloss times the change in time of that one segment squared. And then we can also use the first law of thermodynamics, which is equal to the change of the energy in the system. Delta E system is equal to the work on the system from the surroundings onto the system plus the heat transfer. So there is going to be some heat transfer from the contact with the countertop. That is not calculated, and the work is also the equal to force times the change in distance. And because we are using the normal force of the countertop, this is going to be a constant force. So we are just doing this, no integrals are involved. So going on to my tracker video, I'm going to start this, see it bounces a few times. I'll pause this right here. You see that there is no force acting on the x direction, so the x direction has a pretty consistent line going up, or in a positive x direction. And then the y direction is where it really changes. It's here is where it's at the peak of its height. When I first throw it, it gets right here, where my mouse is right here, and so that is equal to 2.55 meters. And then it goes down. I'll start this video again for you. It goes up and then it goes down. Context the table. You see right here, because it's not a 0, the center of mass is actually at the center or at the center of like the actual lip gloss area, because the cap doesn't weigh as much. So that's why this is just being based on the point mass, the center of mass of the lip gloss. So that's why the y hasn't reached 0, but there is some contact force coming from the countertop causing the change in direction. So it's going back up. It contacts the counter again right here, and so the contact force then is applied to the lip gloss, making it go back up again, bounce. And you see here it flipped over, and that's just a change of center, or that's just the center of gravity being all wonky on this. It's not a uniform center of gravity. You see it's like slightly shifted right here because there's more product and more mass right here. So that is pretty much what we have. We can find the work of our countertop with this information, mainly the delta y, because the only other force being acted on this lip gloss is going to be theoretically the force of gravity. So gravity is going down, the countertop normal force is going up. And yeah, thank you so much for watching.